Welcome everyone to the ZPNC stream. I'm PR Bamra and I'll be moderating this session. For this presentation, we've got Chris Walker from IBM, who's going to be talking us through capacity planning in a hybrid cloud world. As with every session, we do ask that you leave session feedback at the end. This session is coded session 6BA, and we would also appreciate if you could kindly donate to our nominated charities of the year, which is RNLI and Guide Dogs for the Blind. I'll leave both the links for that in the chat box, so please do feel free to look at that afterwards. In terms of questions and answers for this presentation, please leave any questions, feedback, comments in the chat box, and Chris will have a look at them at the end and answer them as well. So with that in mind, over to you, Chris.
Okay, thanks, Bear. Good afternoon, everyone. My name is Chris Walker. I am a product manager at IBM. I've been with IBM about 20 years. First 10 years were in the UK in the Hershey lab, and the last 10 years I've been out in the US, where I'm talking to you from this morning here. Today I'm going to be talking about about performance analysis, capacity planning capabilities. I'm going to be talking about one of the products that I work with closely, which is Z Performance and Capacity Analytics. And in this session today, I'll go through a little bit of background on challenges for performance and capacity planning, some of the things that we hear when I talk with customers about this. Some of the other challenges they're seen, some of the differences that we think are needed now in a modern performance and capacity planning world, because as you know, the landscape of how we do things is changing. We see a lot more need to respond quickly to changes in the business driven area versus just looking at technology in a siloed environment. And I'll talk through some examples with the performance and capacity analytics. I'll show some of the reporting that we have here, some of the things that we do to address some of the challenges that we see the capacity planners having today, how to answer some questions about what if should we be investing in, and how should we simulate workloads in order to understand what potential changes in our environment may occur. And then I'll also touch on the consumption-based pricing model IBM now has on ZOS, which is called tailored fit pricing, and how that really changes some of the things that you want to look at in for performance and capacity planning. So how you maybe traditionally looking at rolling 4-hour average and subcapacity and optimizing for that. Now thinking about how you'll do this in using a sort of consumption-based model. Okay, so let's really start by diving into the domain of what performance management and capacity planning is, some of the challenges that we see with our customers that are having today. And I've listed a few of them here. These are typical comments that we hear when discussing common pain points that are experienced. Maybe some of these everyone has some form of performance management, capacity planning tooling, or maybe someone who is skilled in that area. It's something that has been a part of the mainframe sort of software IT operations toolkit for some time. And many of you will have probably multiple tools for some overlapping tasks, which in itself is inefficient. We see a lot of people still reliant on homegrown tools that may have been built by domain specialists over a number of years, so someone who really knows your environment. And some of these things are unable to really provide the reporting and functionality required of today. There are assumptions built in to how the workloads are running, how things are all lined up, and this may be changing. We also know that there's a need for quick access to information, get root cause of a performance issue, and really having untimely access to that information for managing workloads and making decisions around optimization can really impact service levels and drive up costs. Given the sheer volume of SMF data that can be produced, it's often understandable to look at ways of avoiding the processing of that during a peak period because of the overhead involved. And that has the result that detailed reporting can't be made until perhaps the next day. Also, who else is using the data? So we could look at other multiple ways of as you process this data, using it for multiple tasks. So obviously, sometimes there are operational reports that you want to about how things today, or week-to-week basis, but also the same data can be used for managerial reports. It can also be used for cost and resource accounting if you're doing something like chargeback or even showback to your internal consumers. And one real aspect that we found that's tied into this is the time taken to create and maintain reports. If you are dependent on one or two skilled users who know how to make SQL requests, construct reports, potentially you're not making best use of their talents and
Sorry, Chris, can
reports.
I just
Yeah.
jump in there?
Yep.
Yeah, sorry to disturb the presentation. Your audio is cutting out every now and again for 1 or 2 seconds, and then it comes back. So I'm just wondering if it's perhaps worth moving elsewhere, or just maybe even reconnecting, but it's just kind of stops for one,
Okay.
2 seconds.
Let's
Sorry to disturb you.
let's see what we can do. Give me, okay, let's see how we go, and
Yeah.
if you keep, just jump in again if it's really causing a problem.
Okay, sure.
Yeah.
All right. Yeah, let's try it again then, and then we'll see. All right.
Yeah, so the last point I was really making was around report creation. That should be, you know, a simple task, and ideally end users should be able to self-serve them, or customize in order to do this. So what we hear a lot about today is AI ops, and I don't want to go too deeply into this at a high level. I want to get to the actual domain that we're looking at, but really one focuses of when we talk about AI ops is to address inefficiencies within current tooling and processes that can hinder operations teams to detect they have a problem, work through the root cause analysis, isolate the issue, and really implement the solutions and finally verify that everything is solved. If there's any inefficiencies within that, suddenly that whole process slows down, and that has a direct impact on business performance and overall performance. The folk trying to use AI within this is to really empower the operations teams so that they have the ability to diagnose this quicker, to triage things, understand and explain what the issues are quickly. So rather than spending a lot of time in war rooms or sifting through data, or even just being dependent on a handful of people to actually know the environment specifically, we're able to use some of this so we can get to a resolution quicker. In this particular presentation, we're really going to focus on the center part there, which is the diagnose stage, where the mean time to know is a critical metric to be aware of. You may have detected you have a problem, or you have a question to address, but the time taken to pull the right information together, analyze it, make a decision, can be a costly one if you don't know where to start and don't have the right tools to do this. So we see this, just to emphasize where the value is here, when you're adopting strategies that can be real business value in doing this, whether it's reducing the outage time of a severe outage, maybe it's freeing up your talent within your team to focus on fixing problems instead of fighting fires. The mean time between failure increase can really improve and save the business financially as well. So you're moving towards more productive, efficient resources. Getting some of the most boring jobs done faster can really mean that people can cover work, can work on more optimization and actually improve things. And we've really seen a major shift in how teams are operating today, in order to, instead of being judged in a very siloed environment, maybe just looking at their particular infrastructure domain. We're starting to look at things being judged by business results, and we look at end-to-end views around going from how the overall composite application that may include the mainframe are being judged. And ultimately, that means that some of and the processes that perhaps were
Sorry, Chris, it's cutting out again. Sorry to jump in. Can't hear you at the moment. One second. I still can't hear you, Chris. If you're trying to speak, just give it a few more seconds for the connection to stabilize. Thanks for bearing, everyone, whilst we wait for Chris to reconnect. Yeah, if you could just please bear with us. I think hopefully the audio should improve. But this is one of the joys of doing it virtually, I guess.
Okay, is that any better?
Yes, I can hear you now. Yeah, it just completely cut then, but I can.
Yeah. I think I had a little bit of network problems, but I also have disconnected from my VPN into, and I think, let's fingers crossed that actually will improve things.
Well, it's coming across loud and clear now. So yeah, so let's see.
Well, there you go. I'm going to blame the VPN on that one.
Yep. All right.
Okay.
Yes.
All right. Where were we? Okay. So here's a diagram we use to really help people understand the differences between how they might be doing things today, where they aspirationally want to get to, and what we think is going to be needed in the future when you're looking at things such as performance and operations generally. So it's fairly simple to understand. There's 4 stages here, and if you think down on the bottom left there, we have firefighting, and we all understand what that is. But really, just to be clear on it, it is where your IT organization really isn't prepared for issues, where you have performance problems, where you have outages on a regular basis. And the result is you have to throw your skilled personnel at the problem to resolve it. You may have outages for long periods, and there is no opportunity to improve things. The next stage is reactive. So you have some procedures in place to resolve issues, and you do still get outages, but they're shorter, and you result in shorter resolutions time. As you get to a more proactive stage, you're now looking at the ability to use the data that you have available to you, organize around the issues, and try and address things before they become major outages. But ultimately, where we want to get to is an intelligent stage where we start adopting things such as AI that can assist with identifying anomalies before even there is an observable to the end user problem. And we're looking at things that are non-trivial now, and we can able to remediate them before they become a service disruption. Now, when we talk to a lot of customers, what we find is they're somewhere between reactive and proactive. Everyone, and the mainframe is because of its maturity, have a lot of processes in place. What we're beginning to see, though, is that people have beginning to move away from a lot of the things that this is how we've always done things, to how can we be better with this, and also bringing in or aligning the mainframe more with some of the tooling and some of the processes that are the mainframe connecting to in order to look at composite applications. So how do we really become more intelligent with our solutions? So some of the fundamentals remain the same. We need to collect information about our environment, both from historical and also currently what's going on today. but we really need to consider how we use this data, how we collect it. And typically you build up a historical database, and so you have a profile of how the system performs, including that's to reflect some of the uniqueness that reflects the workloads and the setup that you have there. Where are your peaks in terms of where your peak processing is occurring, when is certain systems quieter, and we can then take that information that's being gathered today to see how we compare to expected levels. So are we beginning to see deviations in terms of performance versus traditionally we have static thresholds or alerts that can tell you if there's a particular spike or problem, but that still is quite reactive. Static alerting is often expensive to maintain, and I'd say there's a high chance that there is a likelihood of some of these being incorrect, because you need to spend a lot of time updating your thresholds to make sure that they are up to date with the workload profile that you've got there. So that's maintain those. The alternative is that you just let these alerts fire, and the operations team are knowledgeable enough to know which ones are the important ones to react to, and which are the ones that just flash up and we know that that's not a real problem. Even more importantly, we need to start looking at trends with the data, so we can see where potential long-term decisions need to be made, maybe due to capacity growth over time. When should we be considering new hardware, additional zip capacity? These are all expensive capital investments, and it's important for capacity planners to deliver accurate estimates so that we have the right decisions and we can optimize the resources that are already available. And I've already mentioned this, but a lot of people are moving to consumption-based pricing on ZOS, and again, so some of the assumptions around how you want to configure and measure within your environment will have changed, and that also opens up more space for optimizations as well. A lot of the future things that you want to take into consideration, or say non-historical inputs, as the slide says, can be fuzzy or unstructured as well. You know, do we think our workloads will grow by 3% next year or 5%? What about each year as that compounds on? What will the effect be? If you know that there is going to be a merger or bringing in sort of one-time major change of the workloads on your system, how do we account for that and deal with that forecasting? So all of these need to be viewed with in terms of how this is going to work, and then identifying where to really deep dive and validate your calculations. And as you'll see, forecasting and simulation provide that ability to answer those sort of what if type questions. And all of these need to be delivered in a more automated process, going really straight from the data collection process. So having that in near real time, not relying on a batch process, 6, 12, 24 hours after something happens to get the information, to how the data is processed and aggregated. We need to be able to have the ability to look at key insights that can be pulled out without heavy dependencies on a handful of subject matter experts, or that one person who knows all the foibles and all of the oddities within your environment in order to do a correct interpretation. So many of the organizations we speak to have staff that really don't have this tribal knowledge and don't have the luxury of spending a huge amount of time to learn all of those oddities as well. And then also as well, understanding the purging and retention of data as well is important. So as you build up this historical database of how your system performs, how do you want to keep that database well managed, understand what data is in there, and storing maybe very detailed data for a short period of time, but also keeping summarized data about how the environment is performed for potentially years as well. So as I said, one of the things that I'm going to be talking about really and focusing on is one of our offerings to address some of these challenges, which is Z performance and capacity analytics. This has been built on a long heritage of capacity planning and performance analysis products that IBM's had, and this is the latest iteration. And we really focus on addressing three key focus points with it. Firstly, we look at the performance analysis, so measuring and checking of the performance in terms of the productivity, taking the data you have about the environment and the workloads, and focus on drawing out insights about changes in performance and supporting those subject matter experts. Think of that partially as kind of a reactive stage within this. However, we then want to take that so that we can look at things such as capacity forecasting to ensure things like the capacity, the infrastructure is able to deliver the agreed service level targets in a cost-effective manner. And we're not just using this for reactive analysis, but now proactive tasks that can help the business make the right decisions. And thirdly, tying that all into cost management. So you are able to give an accurate view of the use of the IT assets and the resources in providing IT services. So that could be something like chargeback or showback to consumers, or even just check in how you are performing against your expected goals so that you don't get an unexpected bill from IBM at the end of the year in terms of where your usage of the system has been. So what, in terms of the data sources that need to be used in order to capture all of this, obviously SMF data is prevalent here, but we also can get data directly from RMF, and IMS with its, typically relies on its logging capability to get a lot of information. We can pull all that information and then start to do analytics on it. The other part of this is that we were able to show information from other systems off the platform. So if you wanted to collect some data from a power system or from a distributed system, that can be loaded in. The scope of the data isn't really fixed. So it's a structured log processing utility. So any kind of structured log could be used and can be expanded into that. So if you have something unique that could be leveraged, that can be written as a custom component in order to feed that data in as well. So that gives you the ability to create some tables that show a lot of detailed information across a lot of different data sources. And as the data comes in, we process it or as we term it, curate it, to take the raw SMF data, apply calculations and summaries before storing that table within a DB2 database, which can then be queried at any point to build reports. The important thing, though, is that while the data is vital in the table, the real important thing is to be able to report on that and draw out the insights quickly. So, both the ability to have predefined and also expand on that is very important. So some of the reports that you want to focus on can be used for many different end users within the environment. So firstly, you'd want to see management type reporting for looking at a high level view of the performance and cost to influence decision making. So they're looking at not particularly detailed low level information about things, but a manager would be wanting to look at how are we tracking against goals, how much, what was different between this week and last week, what's our expectation for the next month. But there's also a need for some technical reporting to help the experts in their analysis and investigation. So maybe there's been an alert on a particular problem. Let's take a deep dive into how KICS has been performing using the 110 records, see what's changed within the environment on that, and look at that information as well. Increasingly, we see a need for enterprise-wide reporting. And what that means is Z is not isolated within the IT world. Your mainframe applications and workloads are being driven by things off the platform. a mobile banking application coming in through ZOS Connect, Kix driving transactions there, updating DB2 databases. It's important then to correlate and understand how that fits with what workloads are being seen off the mainframe as well. So the ability to get the mainframe data into a reporting platform that may be being used for looking at other off-platform reports is also important. So you're able to then integrate your mainframe information with how your front-end application is doing there. We also see there's an increasing need to deliver self-service reports to the end user. That really helps them empower them to access the information they need. It helps reduce the dependency on the infrastructure team to create and publish reports. So think about if you wanted some more detailed report, you don't want to have to open a ticket to then go to someone and say, okay, I need this information. And then they will come back and say, well, we'll have that information in 24 hours or 36 hours. The next part I was going to talk about is really around how to really focus on the amount of SMF data that needs to be processed. It can be very difficult to find the root cause of a problem and administer the changes if you don't know where to start. And in a lot of cases, we see people who are collecting a lot of SMF information data just to be on the safe side. We'll collect it all, we'll store it all up, and if we have a problem, then we'll kind of dive in and look for the needle in the haystack. It can be a real challenge in that case to turn those insights, turn that data source really into valuable insights in a timely fashion and make that correct decision what to do. What do you need to collect? What do you need to analyze? A significant amount of SMF data can also be costly to process, and so what you end up having is actually missing insights or being too slow to react because there is just too much to work with, and that really defeats the point of collecting the data. One of the things that we recommend and focus on is looking at key performance metrics. Here we can look at a significant set of essential information that's been identified by subject matter experts as typically a good place to start and focus on. Really, this would be an out-of-the-box assessment of how the system is performing. Maybe that's just looking at how the CPU is doing on a KEC or on particular LPARs, how much storage is being used, and those things. These will give you key pointers in terms of where the potential issue might be. You can scale across the different systems and then understand where to drill down there. This is also achieved while lowering the overall processing seen with SMF data. There's several parts to that. Firstly, that key performance reports reduce the amount of data needed. So it's identifying, because we've identified which are the key metrics to focus on, we've also cut down on the amount of SMF data that's needed. So you only collect what's needed, and then if there's more information that you need, you can expand upon that. Together with an architecture that feeds the data into the hub of the environment in a continuous fashion. So rather than looking at a batch load of a large amount of hours worth of SMF data overnight, a continuous drip process of streaming the data in keeps the overheads of actually processing that data pretty low in comparison. And that's also augmented by a lot of zip eligible processes in there, so that this gets you away from both concerns over overhead processing, but also getting timely access to the data as well. So let's look at an example of some of these key performance reports in more detail. I've got a few slides now that will just give you an idea of the interface and also some of the things to look for. So just to describe the interface briefly, What we typically have in our reports is the ability to set some filters in terms of the granularity of the reports. So we'd be able to store data both at the SMF interval level, but then also apply summarization so that you can look at things at a more broader scale. So if you can see here, for example, we're looking at an hourly report. We're also able to then filter on different systems. So we picked one system here. We're looking across all workload periods. We're looking at the general processor across several days as well, and filter this in terms of dates and times and this. Each line here represents a different day across a 24-hour period. So you can see that most of them follow a normal pattern, probably driven by batch workloads, but some have different patterns at different times. We might want to look at why that's occurring, and then by selecting that particular individual day, we can then start to look at that day more context and understand what actually happened on that day. One of the other aspects here is that you can see that actually the days are actually all hyperlinked. So you can actually start to drill down in context into looking at certain reports. So here we picked that sort of anomalous day, and we're now wanting to look at what was running on, or in this case, which LPARs within the system were running at that time, where the workload was running. So you can see on the stacked bar chart each LPAR and their relative contributions to the overall processor usage on that day. So what if we think that the hourly wasn't granular enough? We know that there was a high point at 5 in the morning, but we can go, as I say, into more detailed information. And I've selected now the SMF interval to take a closer look, and we can now see the breakdown as that goes across in a far more granular detail, which I think probably on this one is every 15 minutes as we look at this. Oops. And then after we look at that, well, let's take a look at what the workload was doing at that particular time as well. So we'll now drill down to the workloads for the same periods, and we get a breakdown in terms of understanding, well, okay, there's certain work running at that interval, and then that from that point into the service classes, and we can see different mix of work that was actually running at that point and what was contributing to the overhead. And probably got some batch workload here that's running, and some system information that's running across the entire day. So we've now in a position to understand, okay, where was our peak? What was the workload that was running in that peak? And we can now start to look at that in more detail, understand what that workload was doing, and who may be the owner or who needs to be alerted if there is an action that we determine needs to be done. So those, as a view of the KPM reports, very easy to consume, very easy to start to find a lot of useful information to start investigation into performance problems. These reports really form the basis of what we would call exception-based analysis. So you want to be able to define thresholds that are evaluated as the SMF records are processed, and if they're exceeded, written to an exception report. So you keep an idea of when something might be occurring. The result of this is that you end up with a single exception report that can maybe provide a daily system health check, a potential starting point for investigation for problems that might have been seen. And then you can, if you start to see a spike of particular exceptions, you can move from that into root cause analysis and get to the precise information. So to be clear, this isn't really a replacement for an event alerting mechanism that you might have with your monitoring tool. But with so many different reports you might be wanting to review on a daily, weekly, or monthly basis, understanding where problems are persistently happening might be useful for managing resources and looking at long-term corrective actions. So let's take a closer look into a particular example here. So here we're just showing an exception analysis overview, and what we want to just see is what things are changing over time. So we were able to, what I find more interesting when I look at these reports is not so much the total number of exceptions, but really when they occurred and if they're changing over time. Now, this is a bit of an artificial example because we've got it's a test environment and we've got some workloads on. So you can see there's a dramatic change and we start to see problems on this particular day as we go forward. And we also get to see which systems this occurred. So we've obviously made a change on this system and it's now causing problems. What would also be very useful at a more subtle level is that if you start to see changes increasing over time, so you may be seeing a particular exception hit once or twice a day, perhaps, and that suddenly becomes 3 or 4 times or 5 or 6 times a day. And if that's generally increasing up, then you're beginning to see a long-term trending problem that might be missed by a one-off exceptional alert that the operations team is dealing with directly. The ability to see a trend is very important in this case to make sure that we're not going to be hitting a major problem in the future. So when you're actually looking at a particular problem, you're able to go into more details, have a look at how that particular threshold has been trending over time, and then drill down into looking at in more detail as well, which particular records caused it, what the actual value was evaluated at that point in time. One of the things that really play into this, though, is that you want to start using this data to make intelligent use of identifying unusual behaviors or understand the deviations that come from normal levels. And this has been a real major focus for us. What I was saying back at the start was what we want to be able to use the data for is really not just plot a chart that says here's all the values that we recorded over the last day, month, year, but actually amalgamate that data, try and draw out insights in terms of what's the expected performance on a particular level. So here is what we determine smart path, but really it's an analysis of the MIPS usage on an LPAR at a particular hour point throughout the week. So typically you'd like to see a common behavior over a period of time and understand the deviation from that when it occurs. So about how a system will typically be processing information, there's obviously peaks and troughs throughout the day, and those days are different. 9 o'clock on a Monday is different to 9 o'clock on Thursday, which is different to 2 o'clock on a Thursday. So being able to use the data that you've built up over time to understand what's your expected performance on each particular hour of the week is very important. And here, what we're showing on this basic example is the median performance against the expected pointer each day. So each line represents the expected, and an upper and lower bound, which is in this example 1 standard deviation. And the bar charts represent what was actually observed on those days. So that you can see, and this is again an example, but where suddenly we see a spike of actual activity that's considerably different to what we would normally expect to see at 12 o'clock on a Wednesday afternoon. And you can look at this at various levels of granularity at a tech level, but more realistically, you'd want to look at how things are performing at an LPAR or workload or service class level, so you can get down to do that. Obviously, the more data you feed into the system, the better the profile will be, and the more accurate you will track that information. So here's a couple of more detailed examples that we've seen with actually a more varied workload. So you're able to see how the regularity of the patterns of workloads are, and you can filter on a particular level, and looking at different granularities to look at service class information or maybe job information at that point. And here's a real sort of another great example of how this can help you here, because as the assumptions around the behavior you're looking at change, you might want to look at the alerts and thresholds that you've set within monitoring software and performance analysis tools to make sure they're triggered at the right time. You don't want to have false positives when you're doing alerting. So tied into some of this smart path analysis is the ability to create dynamic thresholds when evaluating the system here. So this is actually a much better example of showing you where the threshold is. What we're doing here is using that analysis and building an upper bound threshold that we want to be alerted to when we exceed that upper bound. So we might want to filter it, put in a level of toleration between the expected performance and what we observe. But when we exceed that, we want to make sure that we get an alert on showing that. So the couple of red circles here are where the calculated expected performance plus the upper bound threshold has been exceeded by an observed workload on that system. So this point, these 2 points, we want to be alerted to, rather than using something static that does not take in the variety of workloads that are seen there, because these are not the 2 highest peaks within the system, but they are the 2 peaks that are reflective of where the observed usage is greater than the expected at a considerable level. And that is very difficult to do or manage with any kind of static thresholding. It's much more applicable to when we want to look at dynamic processes as well. And I'll talk a little bit more about forecasting in a minute, but just to give you an idea of one of the things that we think is very important here, that once you have this information available and analyzed for investigating what's happened in the past, it's really difficult to then try and convert all that into understanding what to do next. So many people are using different tools or spreadsheets or dumping the data out to look at capacity planning in using in-house processes in order to really perform very critical tasks here. If you have this data available already as a basis for forecasting future resource needs, you can then really want to focus on saying, well, based on the observed historical use of the system, what's going to happen next? So taking what's already in the system and then really applying a forecasting algorithm, and there are various different forecasting algorithms that you could use. What do we think is going to happen next? The algorithms that you'd want to apply depend really on the data that you're analyzing. So, you know, a linear regression plot is very applicable to something like storage, where you'd probably see a general trend upwards. Something more complex like a polynomial or Fourier-based algorithm is more applicable to long-term cyclical patterns, such as forecasts at a Keck or LPAR level for MIPS consumption or average consumption. And other things that you'd want to also tie into forecasting is making sure that you make the forecast based on the right day or time of data to ensure that you're lining things up correctly. Often certain events throughout a year can move around. A good example of that is Chinese New Year. So if you're looking at a system collected data for one Chinese New Year, but that doesn't line up with the same date every year. So trying to make sure that you align that data so you're comparing like with like is also very important, and that ties into some of the forecasting that we do with performance and capacity analytics as well. So I'm going to dive a little bit further into capacity planning activities here. And one of the real things that capacity planners have to do is make smart investments. So if you're purchasing new hardware, upgrading to the latest technology, if you're blindly making those capital investments, you can sometimes hit mistakes where the expected benefits really aren't realized to the level that you wanted. Pulling the right data together to make that decision can be really difficult and time consuming. And that's to say nothing of the capacity planner's own skills that needed to make those judgments. So one of the things that we see a lot of people interested in is having to answer the question. So let's consider a common example many capacity planners are faced with. When is a good time for major upgrades, such as getting new hardware in? Performance of workloads can vary considerably. What you might want to do is use your existing workloads to create a baseline. And in the example I'm going to show here is that we have our existing configuration at a KEC level, and below that some LPAR levels. And let's see how you move up to say a Z15 hardware. What would the comparable workload be if it's executed on the new processor? And so this is what we can show here. You pick one particular processor and also apply any growth factors that you want to put into that, and see what the actual impact of that would be. And that would give you a good starting point to understand what particular issues might need further investigation, or what particular benefits you would see from doing this. Another example to look at is when to use zip offload analysis. People are very keen to understand when zips are beneficial to them. People are very making sure that when they invest in zips, they make best use of it. So it's critical to know that what zip eligible workload you're running, when it's running, and if you've got sufficient capacity at the right time of the day to do this. So if everything, the zip eligible is running at the same time, you're going to have high peaks where the zip is in significant use, but there may be idle periods within the day as well. The worst thing would be is if you don't have that balance, and you have zip eligible work now running on a general processor, because at that point you're not really taking full advantage of the zip. You may need to buy additional capacity, or you may need to want to look at how to rebalance your workloads. And as we'll see, that's particularly critical when we get to something like tailored fit pricing, which I'm going to lead into in a couple of minutes. Another example where you can take historical data and use it intelligently for capacity planning is in forecasting and simulation of workload growth. So when you're making changes, different workloads respond in different ways. Online workloads may experience performance degradation, such as when the volume of work increases, and that can lead to missed SLAs and operational problems. Batch workloads can take longer to complete, which in turn has an impact on other workloads if they're overrunning into peak business periods. So you may have known trends of how workloads increase year on year, but other change might be unexpected. So it's often useful to do an estimation of applying different levels of growth over the coming years and see at a workload level what the impact of performance will be, and focus in on areas of interest. Maybe a small amount of consistent growth can be accounted for, but if that continues for several years, is there a cutoff point and a point where you need to look at more detailed planning to take place, either to rebalance the workloads or to start making plans for additional capital expense and justifying that as well. So traditionally, capacity planners would be creating lots of complex models, in-house tooling to build out their planning. And that can sometimes be flexible, rework, assumptions change. One thing that we want to apply here with PCA is the ability to do a workload simulation forecast. So in this example, we're showing a single LPAR and an interval period, and an analysis can take place on what potential impact might be if there are IO delays, if the scale of the workload was to change by a certain percent in coming years. Variables that can be applied include workload growth or decrease factor, if you're thinking that you're going to scale down, hypothetical hardware changes, as we've seen, and you can apply different factors to see a full range of changes that could occur and determine the right level of risk that's being taken on, or understand when is the optimal time to take a proactive action to avert performance problems. So just to show you a little bit more detail here, example of some reports, we've got a heat map here of how both online and batch workloads have been calculated. So we apply different levels of growth into that system, and the heat map will tell you where things are being degraded. And then you can then drill down into other particular reports to look at what is the overall impact. Is the degradation at a point where there is something you need to do? Is there at what point does the batch workload extend beyond where it's actually going to start impacting online workloads within that system as well? I'm just checking the time, but what I wanted to finish up on was talking a little bit around a specific topic that a lot of mainframe customers have an interest in today, which is tailor fit pricing. A lot of customers adopting TFP can have concerns, especially at a technical level. Having spent 20 years planning, optimizing for the rolling 4-hour average, you've probably adopted some kind of soft capping strategy to keep the costs in check. And really, under consumption-based pricing model, that doesn't work anymore. All that happens is if you continue with the capping is that you constrain the resources on the machine, and that can then lead to unnecessary performance problems during peak periods and where workload can be spiky. Additionally, the workloads contributing to your bill covers the entire month and not just the 4-hour periods. So you really do need to have a complete view and understanding of all the workloads that are running every day, every week, of every month. And I know that people are wary of sometimes removing caps because there's a fear that a large workload will come in, consume an excessive amount of resources, and you end up with a really large bill back to IBM. And the truth, that's both unlikely and really can be avoided through effective management of this. So what we want to look at is understanding of how the system is performing and look at what's being consumed on the system. Really focus on what is the consumption within the container, forecast the future usage, and then lead into things such as optimization, opportunities for optimization. When you're comfortable with the management of the resources, you can really start to make a very good informed decisions about where optimization can take place, so you can lower resource consumption because you're looking at everything here, not just a 4-hour period. And the likelihood is that you've probably got a large amount of area that you can focus on and get some really good savings as you go through this. For example, even just taking some application that might be running outside of the peak, outside the traditional peak, that hasn't been recompiled with the latest level of COBOL. By doing that, you're already shaving some MSUs off. So I'm just going to run through a couple of slides just to show you, what you want to focus on when you're looking at MSU consumption management. And here we've got 2 enterprise containers, and we can see as the bar chart is going through across the year how much of our baseline entitlement we've consumed and how much we're getting closer towards the end of the year in terms of the baseline. As we'll see, that not hitting your baseline is not a problem, and also going over your baseline is probably not a problem as well. It's relative to the business to decide that, as we see, as to whether it's going to be growth MSUs consumed, but that may be because you're doing more business, you're pushing more workload onto the mainframe, which is ultimately a good thing. But let's say we want to look at this particular system in more detail. The ability to drive down from looking at the top level view of what the container is consuming. So we have 1 million MSUs to consume this year. Last month we consumed 100,000 of them. Who really consumed those? So as we go down, we can look at the LPARs that have been allocated to the container. Where's that workload been running? And then down to the service classes within there. So you're able to see which particular workloads are actually driving this. Again, although we're showing this on a time-based basis, if everything is consuming at the same time, that's not important, because this is not a being charged on the peak. It is about what is consuming the work rather than when it is being consumed. And the other part of that really is around peak usage versus thinking about we're moving away from peak usage versus average use. I mean, peaks are still important, but for a cost management perspective, you want to start to look at the average use. And this example here is a very good one. We've got two line charts here, one representing the peak usage of MIPS on a weekly basis on the system. And you can see here that actually our peaks have been growing over time. They're considerably higher than they were back at the start of the year. But the average is relatively flat. So that actually probably means that, we're not overall consuming anything more than before. What's actually being consumed is, or what's actually happening is the workload's becoming more spiky. We probably removed some caps and we're able to take advantage of the system to a greater level. And if we dive deep into that, we'll probably see a more spikier workload on the right versus where we were on the left, where the system was probably a little bit more constrained. But because the average is relatively flat, I mean, it's grown slightly there, and we might want to look at it. The impact on the billing is probably far less than you would imagine. But if we are looking at things such as, okay, we're consuming 3% more MSUs than last week, why is that? Do we need to investigate that, and have we got a problem? And the final part of looking at TFP is to look at how we are tracking against that expectation, which is really the baseline. In this example here, we've got a horizontal line representing the baseline for the year. One of the lines going from the bottom left to the top right is, or partway up to the top right, is how much we've consumed. And we've used the forecasting algorithms to understand, well, where will we cross the baseline? And you can see it's happening just before the end of the year, so it's a little bit above the line at the end. Well, is that a good thing or a bad thing? That's really for the business to decide. As I say, if you've grown your business and you've applied more workloads on there, then yeah, you're going to consume more than you are going to start the year, but that's probably paid for itself through the increased business. And you can get an estimate of that cost of that little triangle area above the line in order to understand what additional costs, operational costs might be. If it's not where you want to be, and you think, actually, no, our workload should be flatter than that, the forecast has given you enough time in advance to say, okay, we need to take a look at what's consuming this, because we must be consuming more than we thought. So let's try and bring this back in line earlier. So you can start to do this investigation before it's the start of December and you're going, okay, well, we're over consuming, but we haven't got time to make the changes now. By keeping a good view on a forecast of how your TFP consumption is going, you can really keep it in line with what you need from and align that back to the business needs as well. So with that, hopefully you've been able to listen to me once we fix the mic problems, but I wanted to sort of just reemphasize how important being proactive, intelligent with your operational tools generally is important, but certainly with performance management tools and capacity planning capabilities, it's essential to do this. I spoke using about Z Performance and Capacity Analytics, which is the product I'm associated with, that's really been designed to address these challenges. But the key things that you need to look for are the ability to collect that information, collect the right information, draw out the right insights from this, being able to do forecasting and anticipate problems is becoming far more critical as mainframe workloads become more spikier, less predictable than they've been in the past. The ability to react and anticipate not just short-term needs, but actually long-term needs on the system are important on that. So with that, I'd like to thank you for your time this afternoon, and appreciate any feedback you have on the system. Okay, Piara, back to you.
Thanks very much, Chris. I know we're at the end of the presentation, but if anyone does have any questions, I think we might have space for one or two. Yeah, please feel free to put them in the chat box. Otherwise, you can get in touch with Chris directly via email. So I'm sure he'll be able to answer your questions that way. But yeah, as you mentioned, Chris, that we're grateful if you could leave some session feedback. This session is session 6BA. I've left the link in the chat box. And also, we'd really appreciate any donations to our nominated charities as well, which is RNLI and Guide Dogs for the Blind as well. So we're almost 100% of our target. And yeah, if you've taken any value from any of these GSE sessions, then that'll be greatly appreciated.
Thank you very much, everyone.
Yeah, thanks very much. I think we can end it there. I hope you all have a good rest of your day.
Thanks, Bear.
Thanks, Chris. Really appreciate it. Cheers. Bye-bye.